Hello, everyone. What I intend to do today is to go over a 3D particle equilibrium again to show you how we can use the system of linear equations to solve these three equations in three unknowns. Um, if you check my other channel about math made easy, you will realize that I included a session on Gauss-Jordan elimination method, how to do it manually and how to do it with a calculator. You can check that if you wish. But what I will show you today is that sometimes the equations are not pretty straightforward. They look so complicated. So I will show you how we can simplify them and still solve the problems accordingly. So what I did today is I brought a problem. So that's a problem where we have like some kind of a motor or something, and it's on a plate, and it's hung by like two cables and maybe three cables. I don't know if that's a cable or something else like um, I don't know. It seems like here are three cables, and there is a force pulling it up where the magnitude or the force itself is 3,500 pound. And we want to find the force in each of these three cables, AB, AC, and AD. Again, we have to redraw the free body diagram, but to make it easy, it's better to show the coordinates of each point to get used to how we are going uh, to find or to express these tensions in a vector format. So as you can see, point A is on the z-axis, so it doesn't have an x or a y, so it's 0, 0, and the height is 10, so 0, 0, 10. Point A is in the xy plane, so it doesn't have a z, the z is 0, but along the positive x, that distance is 4. This is the positive y, but it is on the negative y, a distance of 3. So 4, negative 3, and 0. Point C, again, doesn't have a z component. Its x, well, they didn't show the x. They say this distance is d. Yeah, I didn't notice that. Anyway, we can assume let's make that distance 2. Okay? I mean, it can be anything. So let's say it's 2, and along the y it's 3. So 2, 3, and 0. And then finally point D, still also in the xy plane, so the z is 0. It's a negative x, negative 4 for the x. As for the y, it says, you see this distance is 3, and from here back to D is 2. So D has a coordinate of 1 for the y. Do you see that? This is 3 and this is 2, so the difference is 1. And since you account for the y from here, then you get negative 4, 1, and 0. Usually we ask you to redraw the three coordinates of, so we can say this is my x, this is my y, this is my z. That's what you need to do in a free body diagram. Again, last time, because I didn't want the lecture to take so long, I simply just assumed, I drew on this. That's not correct. I was just doing it for save of time, for the sake of saving time. Okay, so I have a force going up here, 3,500 pound. I have a tension TA, and the way we are going to do it is to say, okay, here is the arrow, and it's going to a point A, and then you would write these. So 4, negative 3, and 0, this point A, I'm sorry, this is A, this is B. And A is 0, 0, 10. And then we have a cable going to C. Notice we are not drawing it to scale. We are just saying there is a cable here. So I'm going to call that T, well, let's call it TB instead of TAB, right? And TC, this point C is, we assume this distance is 2. Excuse me, you can assume it anything since it wasn't given to us in the problem. And then we have a TD. Let's do TD like that. And it's going to point D. And point D has coordinates -4, 1, and 0. And now we have a complete free body diagram because I don't need, there is no further information that I need to start solving. And to start solving, I'm going to first, the first thing you do, you express all these forces, tensions, and external force in vector form. So we can start by saying the force F, let's call this F. So everything we write is known. So force F equals, notice it's along the Z, so it's 3,500 pound, and there is a K here, 3,500 K pound. T sub A, again, we don't have T sub A, T sub B, I keep saying A. This point is A. Okay, T sub B is an unknown magnitude of TB times a unit vector. So what is the unit vector? The unit vector, I'm going from 0 to 4, so that's 4, 0 to -3, so -3, from 10 to 0, -10, over the square root of 4 square plus 3 square plus 10 square is 125. And this, notice that when you write a vector, you can write it as a component form. So everybody knows that this is the I, this is the J, this is the K, because you are using commas between them. Or this is the same as saying T sub B, let's say over root 125 times 4I minus 3J minus 10K pound. Either or. This is a vector form. This is called components form because I give you the X component, the Y component, the Z component. Both are fine, okay? Like this, you can write it as 35, or you can write it as 0, 0, 3,500 pounds. So it's better to be consistent. In fact, since we are not going to use vectors explicitly, right? So it's better to write it in component form. It's easier, right? So let's do that. So when we go to the T sub C, we can say T sub C over something that we will calculate. I'm going from 0 to 2, 0 to 3, 10 to 0. So it's 2, 3, -10, 4 and 9, 13, and 100, so square root of 113 pounds. And finally, T sub D, similarly, would be TD over some value. I'm going from 0 to -4, 0 to +1, and 10 to 0, 16, 17, 117 pounds. So I wrote all my forces in component form. Now we are going to write the 3 equations of equilibrium. Summation of the forces in the X equals 0. Along the X, this component is 4 over square root of 125 TB plus 2 over the square root of 113 TC minus 4 over the square root of 117 TD equals 0. The second equation, negative 3 over root 125 TB plus 3 over the square root of 113 TC plus 1 over the square root of 117 TD also equals 0. Summation of the forces in the Z equals 0. I get negative 10 over root 125 TB minus 10. So all of them are negative 10, right? Minus 10 over 113 TC minus 10 over root 117 TD plus 3,500 equals 0. So I can write it as negative 3,500. Notice that because the bottom equation is all the terms are negative, you can multiply right and left by -1 and make them positive. And since all of them can be simplified by 10, I can take this 0, 0, 0, and 0. And now I can write, or I can find the equation, or the three equations, and write them in an augmented matrix form. And someone would tell me, oh my God, I have radicals. How can I treat these radicals? It's almost impossible. How can you? It's going to be so complicated and so convoluted, then most likely we'll get it wrong. And I say, I agree with you. So what are we going to do here is a little trick. Let's create 3 new variables. And you say, oh my God, he's going to make it even more complicated. Bear with me for a second. I'm going to pick any 3 letters. I can use X, Y, Z, but to reduce confusion, since we are using summation of the force in the X, Y, Z, I'm not going to use those. I'm not even going to use ABC or ABCD or something because we already said TA, TB, TC. So just to be on the safe side, maybe I can use U, V, and W, 3 letters that we are not using. And I'm going to say let U equals TB over root 125 to get rid of this root, okay? And V equal TC over root 113, and W is TD over root 117. How would that simplify my problem? Now I can write the augmented matrix as follows. Now, TB over that is U. So this would be 4U. Notice we usually don't write anything on the top, but I'm just showing you that this column would belong to U, that column would belong to V, that column would belong to W, and that column would belong to the right-hand side. As I said, you don't do that. I'm just in the beginning trying to show you how what each column means. I have 4, 2, negative 4, 0. 4, 2, negative 4, 0. Then I have negative 3, 3, 1, 0. Negative 3, 3, 1, 0. And finally, I have 1, 1, 1, 350. 1, 1, 1, 350. And now we are going to proceed. According to the Gauss-Jordan elimination method, when I start a new column, I want to see, oh, I'm sorry. I want to move this a little bit so you can see everything. I see that there is a 1 here, so maybe the first thing I can do is to use this second elementary row operation. Remember, we can exchange any 2 rows. So maybe I exchange the first and the third like that. And now my matrix would look like 1, 1, 1, 350, negative 3, 3, 1, 0, and 4, 2, negative 4, 0. Instead of dividing this row by 4 or this row by, it's easier, right? You don't have to do it. I still could have divided the first row by 4 and make it 1, 1/2, negative 1, 0. That's fine. I'm just showing you that sometimes we can use one of these elementary row operations even if it's not required, because we didn't have a case like that. After that, and as you know, we want to get rid of the negative 3 and the 4. And I told you in the Gauss-Jordan elimination method, if we are in column 1, we can either add or subtract multiples of row 1 to the other rows. And since I have a 1 here and a negative 3 there, I'm going to say add 3 R1. Why? Because 3 times 1 minus 3 would be 0, so I can make that 0. To make this 0, I would subtract 4R1. It's that simple. So let's do that. Notice that I made, if I left it 0 here and I keep adding, the 350 would remain 350, so maybe it wouldn't wise to replace these two rows. You will see that, but it's fine. So the first row stays as it is 1, 1, 1, 350. And then when I multiply by 3 and add, I get 0. Multiply by 3 and add, I get 6. Multiply by 3 and add, I get 4. Multiply by 3 and add, I will get 1050. That's what I was talking about. Now, instead of these would remain 0 till the end, till the last step, now they have numbers. But it's okay. Now, negative 4 plus 4 is 0. Negative 4 plus 2 is negative 2. Negative 4 minus 4 is negative 8. And then negative 4 would give you negative 1400. I notice here that if I divide the second, now I move to the second column. If I divide this column by 6, I will get 1 and then 2/3, and it's fraction. So maybe I'll repeat and split or interchange these two. You don't have to do it. I could have, done it from the get-go without replacing anything or interchanging anything. I just decided to do that for the sake of showing it to you. So 350, the first row didn't change. I simply gonna write these as negative 2, 6, negative 8, 4, negative 1400, 1050. And now I want to make that 1. Notice, when you start a new column, if the main diagonal entry is not 1, you divide by that number to make it 1. And that's elementary row operation number 1. We only use it at most 3 times when we start a new column. But since we changed the 4 into 1, we didn't need it in the first column because we ended up with a 1. Here I don't have a 1, so I'm going to divide this by negative 2. So now what I have is 1, 1, 1, 350. 0, when you divide by negative 2, you get 1. By negative 2, you get 4. By negative 2, you get 700. And then this stays the same. Now, in order to get rid of this one, notice I am in the second column. So I have either to add row 2 or subtract row 2 or multiples of to row 1. And of course, here I say subtract row 2. Why? Because when I say 1 minus 1 is 0, so I can get a 0 here. Oh, I'm sorry. Yeah, I get a 0 here. And if I want to get a 0 here, I'm going to subtract 6R2. Notice, in the first column, I was adding or subtracting row 1. In the second column, I only add or subtract row 2. So let's see what we get when we do that. I'm sorry. This is from row 3. So you can see that. So the second row stays the same, 0, 1, 4, 700. If you are in the second column, you don't change the second row. Now, I'm going to subtract row 2. So 1 minus 0 is 1. Didn't change. 1 minus 1 is 0. 1 minus 4 is negative 3. 350 minus 700 is negative 350. 0 minus 6 times 0. 6 minus 6 is 0. 4 minus 24 is negative 20. Right? 1050 minus 4200 is negative 3150. Right? Notice if you add these two without the negative sign, you get 4200, which is 6 times 700. And now I am in the third column because now I have 1, 0, 0, 0, 1, 0. So I have to divide this row by negative 20 to make this 1. And that will give me 1, 0, negative 3, negative 350, 0, 1, 4, 700, and then 0, 0, 1. And when I divide that by 20, the 0 and the 0 cancel, and it's like I'm dividing 315 by 2, right? And 315 divided by 2 would be what? 157 and a half? And right now, I already found that W, notice UVW, W is 157.5. I can write this right away. W equals 157.5. Now, let's see what we are going to do after that. I have a negative 3. I'm in the third column, so I add 3, row 3. Notice, row 1, row 2, row 3. Only row 3. Here, I subtract 4, row 3. And that will finally give me, notice the bottom row doesn't change. I add 3. So 1 plus 3 times 0 is 1. 0 plus 3 times 0 is 0. Negative 3 plus 3 is 0. And this plus 3 times that is what? 522.5? Oh, I'm sorry. I multiplied by 3 only. 472.5. You can use the calculator, it's better. So let's say 157.5 times 3. Yeah, 472. And then you subtract 350. So you get 122.5. Then you are going to subtract 4. So this becomes 0, 1, 0. And then when you multiply that by 4, we said this was like what? It was 315. So 630. 630. So you will end up with 70 here, right? 700 minus 4 times 157.5. Yes, it's 70. So we get U equals 122.5, V equals 70, and W equals that. I didn't want U, V, and W. I really wanted to find TB, TC, and TD. So I say TB equals U times that, so 122.5 root 125 pounds, or TC equals 70 root 113 pound, or TD equals 157.5 root 117 pound, 4. So now, even though my three equations were so complicated, I used this trick to make the numbers integer and small and solve till the end. And finally, I can use my calculator now and say 122.5 times root 125, 1369.6 pound, 70 times, times the square root of 113 is 744 pound, 0.1, or just 44. 157.5 square root of 117 is 1703.6 pound. And I solved the problem. So I found the tensions, and I knew they were tensions, and all of them tend to be positive, so that's a good sign. It's not a proof. Now, let's see if we were allowed to use the calculator. How? Again, if you go and check back what I did with the Gauss-Jordan, I'm going to repeat it here. So what I'm going to do is to create a new matrix. I already had a 3 by 4 from last time, but I just need to change the numbers. I will enter 4 over the square root of 125, 2 over, again, I could have done it without, oh, I'm sorry, 2 over the square. I could have done it with the UVW and then multiply at the end, but I want to check to see if we did the math correctly. The square root of 113. That's the problem, is that it's tedious. We have to enter all these numbers, all these roots and stuff. And then the right-hand side was 0. I have -3 divided by the square root of 125. 3 divided by the square root of 113. 1 divided by the square root of 117. And then 0. And then 1 divided by the square root of 125. 1 divided by the square root of 113. 1 divided by the square root of 117. And finally 350, because we deleted the 0. Now I'm done entering the matrix. Next, I quit, come back to the matrix and use math and go up until I find RREF of matrix A. And let's see what we get. Hopefully I didn't make many mistakes. 1369.6, 744.1, and 1703.6. Perfect. It worked. And it has to work if you enter the number correctly. So again, if you have a calculator and you are allowed, and most likely they would allow you to use it in an engineering course, since the math is too tedious, especially if you don't use this trick and you start to try to use Gauss-Jordan elimination method with these roots. Oh my God, that would be really bad. But if you were allowed to do it, or if you are not allowed to use a calculator, as I told you, use some new variables to simplify your work. Otherwise, of course, use a calculator. Okay, I hope this was clear enough for you. If you have any questions, let me know by dropping a comment in the comment sections, and I'll do my best to come back to you as soon as I can. Thanks and have a great day.